All right, Wednesday lab group, we're going to do the Resistance is Futile lab virtually. So to start us off, we'll get the title down, Resistance is Futile, and then parentheses, that's Ohm's Law Lab. Feel free to pause at any moment and get all that copied down. Then you'll get into your research question. What relationship exists between the voltage across and the current through a resistor in a circuit? Once you get the research question down, please make a hypothesis. How do you think those variables will relate? The next section, we're just going to have some background. So we'll make a section of background notes, and the first thing we'll talk about is voltage. Voltage is the difference in potential from one location to another, and it's always measured across a device, whether that be a battery or a resistor or just any two parts of a circuit, always measure across. An analogy of that would be like the steepness of a hill, or how high the change in height would be. We'll measure it using a voltmeter, and a voltmeter's job, again, we want you to have that definition down. It measures voltage, V, in units of volts. And we'll zoom in so you can see the setting that you'll need to place a voltmeter in to get voltage. So you see where that dial is recorded. You can pause this and kind of sketch that. It's pointed at that 20 dCV. That's how you'll get voltage values. And the next thing that you have to have down is current. Current is the amount of charge flow through a circuit per time, and it's measured through a circuit, not across like voltage. So that's actually how much charge is flowing through per time. And the analogy there, it's like water flow rate. So the amount of water rushing through a river, whereas the voltage is more like the steepness of the hill that the water's rushing down. A current meter, sometimes called an ammeter, it measures amps of current. Amps is the unit, but current symbol is a capital I, so we want you to have all that copied down as well. And then we'll zoom in so we can see the setting that the current meter has to be in. You see the red port is on top and the black on the bottom, and then the setting is set to that 10A diagonally downward. Please sketch that. The battery that we'll be putting in will supply the voltage or the potential difference for our circuit. That's what's going to drive the charges around. And we're going to be sending them through this ceramic resistor. That the charges will flow through that and kind of heat up that material. And so the overall setup of our circuit looks like this. Our current meter will measure the current for us through the wire. The voltmeter will measure voltage across that resistor. Please set up a data table of X and Y axis. Current will be on your X, voltage will be on your Y. We'll be putting the batteries in this little housing like this and connecting, and just keep putting more and more batteries on. And you see how that wire has to keep changing where it's placed, that we tap across the full potential difference of those batteries. Ultimately filling up a whole battery pack, and then we can keep adding more on from there. If we trace the flow of electricity through our circuit, we're kind of going through the wire here, into the resistor, back out into the amp meter to measure how much current is flowing through there, and then all the way back around to the other end of the battery. And once we make that connection, then we have a complete circuit, one on the positive side, one on the negative side. Now we actually have current flowing through the circuit, and we can get our values recorded from our voltmeter and our current meter. We'll start off with one battery to start getting our data collected, and with one battery the current meter reads 0.02 amps, and the voltmeter, once we hook it up across here, you got to tap across that resistor to get the voltage. Once we tap across, we get a voltage of 1.09 or 1.1 volts. So record those down in your data table. Again, feel free to pause and back this up or to get all the data. With two batteries, our current reading is 0.04 amps, and the voltage is 2.18 volts. Just gonna keep cruising through this. Three batteries make the circuit. We get 0.07 amps for current and 3.37 volts. Four batteries, 0.09 amps and 4.62 volts. Now, to do more batteries, I had to kind of take one out and then make a connection. So now I'm up to 5 batteries, and I just used a wire to kind of bridge over to the next battery pack. So now I got a full circuit with 5 batteries. 5 batteries, I get 0.11 amps and a voltage of 5.67 volts. Up to 6 batteries now, 0.14 amps and 6.95 volts. It's jumping around. Let's say 6.97 volts. Last one we'll take is 7 batteries. And so for 7 batteries, the current is 0.16 amps and the voltage is 8.12 volts. Alright, once you get to that point of having all your data collected, then we can make it up in Logger Pro. And this is what you're going to want to have done for Thursday. So let me just show you how I labeled my columns here. Current on the x-axis, the shortcut name for current is an I, capital I, and the units of that are in amps. You can shortcut that to just capital A, but I want you to write it out for now so that you know what the full unit is. But you may see current just displayed as capital I. So that's done, and then voltage is shortcut name just capital V, and then the units are volts. So I'm just dumping the numbers in that we collected, and make sure you got current in the right column, voltage in the right column, but then you'll just start building your graph. I don't remember the exact voltage values, but something like this. And then make sure you auto scale it, put a title on that, and we'll bring the graphs back on Thursday. If you have your graph done and printed, that would be ideal for Thursday. So have it like in your journal ready to go, print it out so that we can just kind of wrap that up and finish it in class Thursday. And because I feel bad you didn't get to really experience the lab, you get to watch special footage of my son running away from me and trying to hide the Spider-Man ball from me. Enjoy.
You give me that. Bonk. Hey, you give me that. Give me that back. Give me that back.